Hey guys, welcome to Fundamental of Mechanical Design, where we're going to look at the concept of centroid. So, if you've ever looked at a centroid problem and just thought, okay, where do I even begin? Don't worry, we're going to solve this one together, step by step. This type of shape area is a composite shape, and you are going to find most of engineering cross-section areas, which are composite shapes, which means they can be breached into multiple simple shapes like rectangle, triangle, and circle. So here's our problem. We need to find x bar and y bar, basically the centroid coordinates of this shaded area. First thing, let's understand what we're looking at. The origin is at the bottom left corner of the shape. Now the shape itself, it's a trapezoid, and then there's a circular hole punched through the middle of it. The dimensions we're working with, total height is 125 plus 125, so 250 millimeters. Across the top, we've got 200, then another 200, then 150 millimeters. And the circle, the radius is 60 millimeters. Now here's the key idea. We don't try to solve this complex shape directly. Instead, we break it into simple shapes that we already know how to handle. That's the whole game here. This approach is called the Composite Area Method, and the idea is actually pretty intuitive. The centroid of the whole shape is just the weighted average of the centroids of all the individual parts, weighted by area. So mathematically, and I'll write this out, x bar equals sum of A times x bar over total area. Same thing for y bar. Now for the whole, here's an important point. A whole means we subtract that area, we treat it as a negative area. That's it. So our three parts are the rectangle, positive area, the triangle, positive area, the circle, negative area, because it's a whole. Okay, let's go through each shape one by one. Shape 1, rectangle. So the rectangle spans the full height of the shape, 250 millimeters, and it's 400 millimeters wide. So the area is A1 equals 400 times 250, which gives us 100,000 square millimeters. The centroid of a rectangle is just at the middle. So x bar 1 is 200 millimeters, y bar 1 is 125 millimeters. Easy, right? Now the triangle, base of 150 millimeters, height of 250 millimeters. A2 equals half times 150 times 250, giving us 18,750 millimeters squared. For the centroid, remember, the centroid of a triangle is at 1/3 of the base from the base edge, not half, 1/3. A lot of students mix this up. So if the base is B, then from the height, it is 1/3 of B. And if the height is H, then from the base, it is 1/3 of H. So x bar 2 is 400 plus 150 over 3, which is 450 millimeters. Y bar 2 is 250 over 3, which is 83.3 millimeters. And finally, the circle. The radius is 60 millimeters. A3 equals pi times 60 squared, giving us 11,310 square millimeters. From the figure, the center of the circle is at x bar 3 is 200 millimeters, y bar 3 is 125 millimeters. And again, this one gets subtracted, which is a negative area. Alright, now we put everything into a table. I know tables look boring, but honestly, this is what keeps your solution organized and error-free. So here's how we set it up. Each row represents one composite shape. So we have rectangle, triangle, and the circle hole. For the columns, the first column is the area of each shape. Remember, the circle gets a negative sign here because it's a hole. The second and third columns are the centroid coordinates, x bar I and y bar I, for each shape. Then the fourth and fifth columns, we just multiply. Area times x bar I and area times y bar I. And at the bottom row, we sum up each column. Total area is 107,440 millimeters squared. sum of A times x bar gives us 26,175,500 millimeters cubic, and sum of A times y bar gives us 12,648,688 millimeters cubic. Now, pause the video here, hide the table, and try to redo it yourself from scratch. You already have all the values. This is honestly one of the best ways to make sure you actually understand the method, not just follow along. Now the easy part, we just plug into the formula. For x bar equals sum of A times x bar over total area. So 26,175,500 divided by 107,440, which gives us approximately 244 millimeters. And for y bar equals sum of A times y bar over total area. So 12,648,688 divided by 107,440, which gives us approximately 118 millimeters. And there we go. X bar is 244 millimeters and y bar is 118 millimeters. If we locate the centroid in the area, x bar 244 millimeters, this should be here. And y bar 118 millimeters, this should be roughly here. So this is the location of the centroid, which is at the whole area of the composite shape. If this helps, do hit the like button. It really does help more students find the video. Next up, we've got another centroid example, different shape, same method, so you can see how it applies again. Don't forget to subscribe, like, and share, and I'll see you in the next video.